Okay, so the next unit is domain and range and piecewise functions. And so I was like, you've done this before, but I just need to go over it. It's not weird behind my head. That's actually this light. That's just the light in the room. And so it's really weird that's reflecting like that on the picture behind me. So that's kind of cool. Anyway, so the domain is the x values, and the range is the y values that pop out. So for example, like y equals x plus 2. So we see that I can stick in every single x value, and I can get at any y value. And so the x values are all the reals, and the y values are all the reals. That's the range values. The book brings up a point. Let's look at this notation or this coding. I put open bracket. Let's see, 1 is less than x is less than 5. Oh, hold on a second. It's less than 5. So what happened? What's the idea here? So let's see what's going on here. We still have the same. Whoops. We still have the same. We still have the same line, but it's kind of like stop. So we see that the domain is now from 1 to 5, and therefore, what's the range? The range is now what? It's 3 to 7, and that's the idea. Once again, the domain is the x values, and the range is like what y values you can get out of there. So let's just look at a couple of relations that we've looked at. So this is a linear. We've looked at. Let me take this restriction out. We've restricted the domain. We're back to everything real and real. So let me change the function. So we know that polynomials. So let's talk about the domain. All polynomials, the domain is all the real numbers. So for example, let's say I say x squared. Well, you know what? Let's do it like this. So let's do like x like plus 1. So that's real. Let's do like x plus 3. Right? And so what do we have? We have a parabola, right? But once again, I can stick every x value in, and I can stick every x value in. Let's do a cubic, like x minus 4. Once again, there's no restrictions on the x, and so on and so forth. I can keep like adding in, x, minus 7. I can keep. The idea is there's no restrictions on this. So let's see. So all polynomials, the domain is reals. As I said before, as I showed before, unless I restrict the domain like from 1 to 7, in general, the domain is all real numbers for polynomials. But what are some other functions we've looked at? Well, you studied like rational functions. So let's take, for example, like y equals 1 divided by x minus 5. So we can see here that in this function, here we can see that the domain is all values except for 5. So whenever you have something in a restriction in the denominator, this affects or restricts our domain. What about rationals? How about and just the same, you studied also like 2x plus 5 divided, 2x plus 5. Let's close that up. 2x plus 5 divided by like x minus 2. Same idea. We're going to be talking about the range and the horizontal asymptote, but right now we're just talking about the domain restrictions. Once again, x can be any single number. It just can't be x equals 2. So let's continue with our thinking about the domain. Let's look at radical functions. So we have y equals like the square root. So down here, let's see. Let me hide this. Radical x minus 4. So you notice, wait a minute, the x values start at like x equals 4, and you realize, when we're talking about domain and range for the real plane, I can't have a negative number under the radical. So my domain is x is greater than or equal to 4. I can have 0 in there. I just can't have a negative number under there. So once again, my domain is restricted for radicals. What are some other functions we've looked at? How about how about exponentials? Well, for that one, I can say there's no restrictions on the domain. Once again, there's going to be a restriction on the range. I can't get negative numbers out of there. I can't get, no matter what 2 to the x is, I can't get 0. We're not talking about that yet. But I can stick any x value. So for the exponentials, for something like this, I can manipulate that exponent. Like if I do the square root of 2 to the square root, that's a totally different story. I'm talking about the basic functions. Y equals 2 to the x. The domain is all reals. What else have we studied? Logarithms. How about ln of x? Once again, the basic parent function. What's going on ln? What we know that x has to be greater than 0, or that expression. So, for example, I put 2x plus 5 minus 5. That expression has to be greater than 0. So you can see that exactly. You can see this asymptote right here. That's 3. You can see that the asymptote here is 2.5. So it has to be greater than 2.5. So that's ln. What else? Last year you studied some trig functions. You studied sine of x. You can see here it's the domain. We'll be talking about the range values. We see for sine, it maxes out at the ranges from -1 to +1. Just talking about domain right now, I can stick any value in for sine. And same thing for cosine. Once again, the domain is everything. What about tangent? Well, we know that from last year you learned that tangent is sine over cosine, and we see there that cosine is some sine 0, right? So we know there's going to be some domain restrictions on tangent. There's going to be some domain restrictions on tangent, and that's when the cosine is 0. It turns out that the domain for tangent is all real except all values that are 90 plus or minus k times 180. So like 90, 270, 450. So you start at 90 and keep adding and subtracting 180s. All those values are restricted. It's kind of cool. Let's take a look at the range. Yeah, and let's take a look at the range values. So let's go back to the original function, like y equals, what do we start with? Like x minus 1. And we saw here that x minus 1, we can get to every single y value. We don't have any, so let's take a look at the quadratic, like x plus 3. So you say, wait a minute, I can't get at every y value because there's a minimum there. And we learned how to find the minimum, and we will talking about the minimum. But what you realize is that functions that have odd orders, they just, like the cubic, it starts at negative infinity and goes up to positive infinity. Like here, let's do x plus 2. Once these they start at negative infinity and go up to positive infinity. But you saw with the quadratic or the quartic, let's do x minus 7, that let's take that out. Let's make that 1 because it's not pretty. How about 2? There we go. Let's zoom in there. You can see with the sorry. You can see with the quadratics and the quartics that it seems like it's like a W or an M. A W, right? It's a W. It's a W. Oh, come on. It's like a W, or I can stick a negative in front of here, and it's an M. And so once again, so when you have odd order, let's think it's to the 5th power. How about x? How about x? Perfect. We see here that, once again, this starts at positive infinity, goes to negative infinity. Or let me take that negative out. Same idea. It starts from negative and goes to positive, but the So the odd ones, the range is every y value, but the even functions like the quadratics, the quartics, to the sixth power, to the eighth power, they seem to have that m or that w look, and there's minimums and maximums. So you would need to find what the minimum or the maximum was. And now it's easy when it's quadratic. So like let's make this back to a quadratic, and let's zoom in there. We see that the range starts at the minimum and goes to like infinite. It's greater than the minimum, or if I negate this, like make it a frown, whatever that max is, like so the range is y is less than or equal to -1. What else? Let's take a look at the range of rational functions. We're going to be studying this in a couple of units. So like y equals like 2x plus 4 divided by x minus 2. Now you learn that we saw that the domain is x is all reals except for x equals 2. But the question is, what's the range? Is there a y value that we're never going to get at? And you learned last year, and I think we're going to do it again this year, is that there's a horizontal asymptote at y equals 2, and therefore the range is all y value y is all reals except when y equals 2, because this function will never get to 2. Let's go back to radical functions. Let's look at what it was. Radical x minus 4. So the question is, when you look at this function, we notice that no matter what x value, once again, the domain was restricted for x is greater than or equal to 4. But if you notice, we're never going to get negative values out of this because it's the sign next to the radical is positive. If we put plus or minus, we have a little problem. So someone asks, why? If we put the square root of x minus 4, well, and this is actually the solution of x. This is x, equals y squared. Y squared. Let's see. Plus 4? Yeah, so someone says, why is this a function? Well, this is not a function because both the x values will go to the two y values and stuff. But anyway, let's take that out. We don't care. We don't care. The idea is the range we can see is that with radical functions, very basic ones, because I can manipulate this up and down. For example, I could say like -3, and then you'd be like, oh, Mr. Adler, the range is underneath 0. That's fine. Let's just get rid of that shift. Transformation we'll be talking about, and then the idea is y equals radical x minus 4. The domain is x is greater than or equal to 4. The range is y is greater than or equal to 0. What else are we talking about? Exponentials. 2 raised to the x power. It's clear, and we talked about this. This was our second introduction to asymptotes. We see here that the domain is x is all reals, but the y is greater than 0. And we talked about asymptotes, whether this is 2, maybe this is 1/2. Let's change this to 1 divided by 2. Sorry guys. Close that up, and let's raise this to the x. Same idea. This is a decreasing function, and it's asymptotic to 0. So the range is y is greater than or equal to 0. Once again, this is just for the basic. I could negate this. And then, once again, the range for this function is y is less than 0. What else? ln of x. Well, hold on. Let's hold on for this a second. So we have e to the x. This is an exponential function. The domain is x is all reals, and the range is y is greater than 0. If I look at the logarithms, you might have learned last year that the domain of the function is the range of the inverse. So the range of logarithms is everything. And lastly, you learn that the range of the function is the domain of the inverse. And so because the range of e to the x is x is greater than 0, the range, the domain is, we can see here the domain is x is greater than 0. Yeah, the range of the domain is equal to the domain of the inverse. Okay, and you can visually see that. What else do we want to look at? Let's just look at the, let's just look at sine and cosine, sine of x, sine of x. Let's zoom in here. Sorry. You learned let's take that out. You learned last year that the range, which is like the max and the min, the range of sine goes from 1 to -1. And it's fluctuating from 1 to 0, from -1 to +1. And then the range of tangents, nope, it looks like every single value is covered. I think that's it for range and domain. Is there anything else I want to do? Nope, that's it. That's the idea. So you're specifically looking for restrictions. So the idea is, what x values can I put into the function, and what y values can I get out? And that's basically it.